In this video, what we're going to do is explore the difference between theoretical probability and experimental probability. Theoretical probability is what we expect to happen before conducting any experiment. It is based on the number of favorable outcomes compared to the total number of possible outcomes. The set of all possible outcomes is called the sample space. Experimental probability, on the other hand, is based on actual results. It tells us what happened after performing an experiment or conducting a series of trials. All right, let us investigate both types of probability using a coin and a spinner. When we flip a coin, there are two possible outcomes, heads or tails. Our spinner has four equally sized sections, red, blue, green, and yellow. Because we are combining two independent events, we may determine the size of the sample space by multiplying the number of outcomes for each event. There are two possible coin outcomes and four possible spinner outcomes. Since 2 times 4 equals 8, our sample space contains 8 equally likely outcomes. Heads red, heads blue, heads green, heads yellow, and tails red, tails blue, tails green, and tails yellow. Since all 8 outcomes are equally likely, each outcome has a theoretical probability of 1 out of 8, or 12.5%. All right, what we're going to do next is conduct 16 trials. Before we begin, let's make a prediction. Since each outcome has a theoretical probability of 1/8, we can determine its expected frequency by multiplying our 16 trials by 1/8. This tells us that we should expect each outcome to occur about 2 times during our 16 trials. Now remember, that's what we expect to happen in theory. The question is, will the actual results match those expectations? Now we're going to perform our 16 trials and record the results. As we complete each trial, pay attention to how the outcomes begin to accumulate. Some outcomes may appear more often than expected, while others may appear less often. All right, now that we've completed our 16 trials, let's compare the experimental results to the theoretical probabilities. Examine the probability table that's shown on the screen. If you take a look at the far right column that's labeled difference, anything in red means that that outcome occurred less than what was expected, and anything in green happened more often than what we expected. And anything that is in black or 0.0 means there's no difference between the theoretical and the experimental probability. And the only outcome that occurred exactly what we expected based on the theoretical probability was flipping heads and landing on green. That happened exactly 2 out of 16 times, which is equal to 1/8. Flipping heads and landing on blue, flipping tails landing on red, tails blue, and tails green all occurred less often than what we expected. Flipping heads and landing on red, flipping heads and landing on yellow, and flipping tails and landing on yellow all happened more often than what we expected it to. This variation is completely normal. When the number of trials is relatively small, as is the case here, randomness can have a significant effect on the results. Experimental probabilities often differ from theoretical probabilities because chance plays a larger role when only a few trials are performed. So what happens if we increase the number of the trials? Well, the experimental probabilities move closer to the theoretical probabilities. This idea is described by the law of large numbers. The law of large numbers states that as the number of trials increases, the experimental probability tends to approach the theoretical probability. All right, we're going to test this idea by increasing the number of trials to 100. All right, now that we've increased the sample size, notice what happened. The experimental probabilities start to stabilize and move closer to the theoretical values. The differences do not disappear completely, but they become much smaller. As we continue increasing the number of trials, the outcomes become more balanced and the experimental results begin to mirror what we would predict mathematically. This demonstrates one of the most important ideas in probability. Randomness can create noticeable variation in the short term, but over many trials, the results tend to reflect the probabilities we expect. All right, so in review, we should understand that theoretical probability is what we expect to happen based on mathematics and the sample space. Experimental probability is what actually happens when we perform an experiment and collect data. When the number of trials is small, experimental results may vary significantly from theoretical expectations. However, as the number of trials increases, experimental probability tends to get closer and closer to the theoretical probability. All right, thanks for checking out this video. I hope it helped you better understand the difference between theoretical and experimental probability and how the law of large numbers helps to explain why results change as more trials are performed.